Every time you hop in a car, you are sitting just a few feet away from an absolute masterpiece of engineering. Hidden right under the hood, there's this incredible, high-speed ballet of controlled explosions, physics, and perfect timing that, and I mean this literally, moves our world. So let's dive into this amazing mechanical symphony.
The basic idea is simple, but the execution is just brilliant. How do you take the chemical energy that's locked inside a single drop of fuel and turn it into the powerful forward motion that gets you from point A to point B? Well, that's the core question we're going to unpack right now.
The answer, well, in a word, is fire. Or to be a little more specific, it's about harnessing the power of thousands of tiny, perfectly timed explosions that are happening inside that engine every single minute.
So, that brings us to the big question, right? How does this metal box not only create these incredibly powerful explosions, but also manage to control and harness them with such unbelievable precision? Let's find out.
Okay, first things first. We need to understand the arena where all this action is going down. Before we can really get into the how, we've got to understand the where. If you look at it from a high level, an engine really has two main groups of parts. You've got the core structure. That's the heavy, stationary stuff like the engine block that holds everything together. And then you have the rotating assembly. Those are the moving parts that are actually doing the work and creating the power.
But the real heart of the whole operation is right here, inside what's called the cylinder. This is our stage. And our main players? Well, you've got the piston, which moves up and down, the valves, which are basically doors that open and close, and the spark plug, which is the ignition source.
So now that we know the stage and we've met the players, let's talk about the performance itself. See, it's not just a single event, it's a continuous, repeating, four-part rhythm that creates all the power.
And this is it. This is the magic behind almost every car engine out there. The four-stroke cycle. It's a really simple, elegant loop. Intake, compression, power, and exhaust. Let's break down exactly what happens in each step.
It all comes down to these four movements. You can think of it as suck, squeeze, bang, blow. Seriously, the piston goes down to suck in air and fuel. Then up to squeeze it, it's forced down by a bang, and then it goes back up to blow the exhaust out. Simple concept, right? But the details are absolutely fascinating.
All right, step one, the intake stroke. The intake valve pops open, and as the piston travels down, it creates a vacuum inside the cylinder. This suction pulls in a fine mist of air and fuel, filling up the chamber. The engine is literally taking a breath.
Next up, stroke 2, compression. Both of those valves slam shut, totally sealing the cylinder. Now the piston reverses course and shoots upward, squeezing that air-fuel mixture into an incredibly tiny space. This builds up a massive amount of pressure and potential energy, priming it all for what's next. And here we go. This is the moment of truth. Stroke 3, power. At the absolute peak of that compression, the spark plug fires. That one tiny spark ignites the whole mixture, creating a massive but controlled explosion. The force of that blast slams the piston down with incredible power. This is the bang that makes the car go. Finally, to wrap up the cycle, we have stroke 4, exhaust. The job's done, so the exhaust valve opens up. The piston travels back up, acting like a plunger, and pushes all those burnt, leftover gases out of the cylinder. The stage is now clear, and the cylinder is instantly ready to start the whole process over again.
So, that's the performance happening in just one cylinder. But a car engine isn't a solo act. It's more like a full orchestra. So let's zoom back out and see how this all comes together into a beautiful symphony of motion. And here's the absolutely critical part. None of this can be left to chance. For this whole four-stroke dance to work, those valves have to open and close at the exact right millisecond. It's not random at all. It is a perfectly orchestrated performance. So who's the conductor of this orchestra? Well, that would be the valve train. A timing belt, or sometimes a chain, connects the crankshaft at the bottom to a camshaft up top. And as that camshaft spins, it has these special lobes on it that push the valves open and closed in perfect time with the piston's movement. Now, if you only had one cylinder, the power would be really rough and jerky. It's why most cars have 4, 6, or even 8 cylinders, and they all have to work together in harmony. They fire in a staggered order, so at any given moment, there's always at least one cylinder on its power stroke. This is what turns those rough individual pulses into a continuous, smooth flow of energy.
So how does all this up and down motion actually turn the wheels? Well, that violent linear motion from the pistons gets transferred to the crankshaft, and the crankshaft's whole job is to convert that up and down motion into the spinning rotational force that will, eventually, make the wheels go round. There's also a heavy flywheel attached that helps smooth out any little remaining jerk.
Okay, with all this high-speed motion, intense pressure, and extreme heat, how does an engine not just tear itself apart or, melt into a puddle? That's where its absolutely essential support systems come into play.
Two systems are the real heroes here. First, lubrication. An oil pump constantly circulates oil all through the engine, creating this thin, slippery film between all the moving parts. Without it, you'd have catastrophic metal-on-metal friction. And second, cooling. Those explosions generate a ton of heat, so a water pump circulates coolant through the engine to absorb that heat and carry it away to the radiator to cool down.
So when you put it all together, it is truly a remarkable thing. You go from one little spark to thousands of perfectly synchronized explosions every single minute, all to turn fuel into motion. This four-stroke cycle, it's the hidden symphony that has powered our world for more than a century.
Which kind of leaves us with one final thought. The next time you start your car and you hear that familiar rumble, will you just hear an engine, or will you hear the intake, the compression, the power, and the exhaust, that whole carefully orchestrated hidden symphony happening thousands of times a minute right there in front